Alrighty. Why is this always there at first? Go away. Alright, so this is obviously 2.5. The title that you see here says multiplying and factoring. Must have been out of whatever textbook I was kind of grabbing examples from, or kind of using as a rough guide for these notes handouts, but we're not going to be factoring quite yet. We'll be factoring a little bit later on, possibly even, actually no, not the next section, but soon enough we'll be factoring. But in this section 2.5, we will only be talking about more multiplying, but we've kind of already done some multiplying with polynomials and monomials and things like the distributive property. So this, where we were recently doing things like the distributive property, 5 times 2n is 10n, and then 5 times positive 3 is positive 15. Or if we were distributing negative 2 times x, and then negative 2 times negative 7. So negative 2 times x, and then negative 2 times the negative 7 is positive 14. But then in a separate section, we were also multiplying possibly things that involved some like bases. So x to the negative 3 power times x to the 8th power. To simplify that, we only need to add the two exponents together. And kind of here, similarly, if you were just focused on x to the first power times x to the third power, that would end up being x to the 4th power. And then y to the 2nd power times y to the 7th power. Once again, you're going to add the powers and get y to the 9th. And then this z, which is technically z to the 1st power, nothing to multiply with and simplify with, so there's just going to be a z. And then the 4 and the 6, well, those are just regular numbers that you've been multiplying together since like 2nd grade. So the 4 times the 6, because really all of this is just being multiplied, even though we're grouping this monomial separate from this monomial, right? It's almost like here's a monomial and we're multiplying it with another monomial. Well, really, if that's the case, like everything's being multiplied together. It's like 4 times x times y squared times 6 times x to the 3rd times y to the 7th times z. So yeah, the 4 and the 6 are going to simplify together, and again, that's just 24. But then again, x, which is technically x to the 1st times x to the 3rd, and then add for the y's, and then, like I said, the z. But that was before, right? So in this lesson, we're really just going to, I guess, combine those different skills, the distributive property along with, because look, I mean, you can see already, I think, how we're going to be combining these skills where we're distributing, right? But as we distribute, as we multiply, we're not only multiplying like a 5, or we're not just distributing a negative 2, we're distributing a negative 3x squared. So we have to do negative 3x squared times 4x to the 3rd, right? So you just got to do a lot of different little baby steps, a lot of little decisions to make, and you got to get them all correct. Because we're doing like negative 3 times 4, which is negative 12, but then the x squared times the x cubed, you add the powers. Okay? So again, we're like on the surface, when you kind of zoom out and just want to describe what we're doing very very generally, or what we're doing overall here is the distributive property. We're multiplying these, then we're multiplying, but every separate multiplication, right, you got to get correct. And again, we're multiplying. I guess what I was getting at there was it's all multiplying, right? We're multiplying negative 3 with positive 4. And we're multiplying x to the second power times x to the third power. But to do that multiplying, okay, you add those powers. So negative 3x squared times what's technically 1x to the second. There's going to be the negative 3, and then we add the powers. And then negative 3x squared times negative 6x. Remember, it's like you're doing negative 3 times negative 6 to get positive 18. And then when you do x to the second times x, what do you get? Hopefully you're thinking x to the third. And then when you do negative 3x squared times negative 7, well, the negative 3 times negative 7 is going to become positive 21. And then there's nothing, to kind of simplify with the x squared. So it's just going to, oh, what the? That needs a little fixed, doesn't it? Huh, interesting. So, yep, there's that example. So again, overall, you can see what's kind of happening here. We're just distributing, but there's exponents now involved with, x's or I guess, I kind of skimmed through there. It could be any variable or variables. There could be x's and y's. It could be just m's, whatever. So this example right here, 4x times 4x times x squared. Remember, we're multiplying. So that's 4x to the third, okay? Because technically we're adding powers. 4x times negative 5x. Negative 20x to the second. Because the 4 times negative 5. And then x times x. And then lastly, with the distributive property, we have to multiply 4x to the positive 8. Which is only going to get us plus 32x. As usual, feel free to pause as needed. Just, again, like nothing, I don't think in these last two examples there's going to be anything new to kind of explain, like no other plot twists or curveballs, really. So here we're just doing x to the third power times all, 4 terms in the parentheses. So x to the third times 4x to the fourth. Well, there's just going to be the 4 because, remember, technically there's a 1 out in front. And then as far as x to the third times x to the fourth, we're going to add those powers. And then x to the third times x to the second. Once again, add the powers. X to the third times negative 5x. Remember, technically that's x to the first. So when we add the powers, it's going to be x to the fourth along with the negative 5. And then x to the third times 1 is just x to the third. And we're done. I guess I haven't, reminded you or brought up the technicality of, remember, you're not going to be done simplifying unless you, what am I trying to say here? You have to check to make sure there's no like terms, okay? Which there normally isn't going to be because there was no like terms in this bubble to begin with. So, I mean, if you think about it, what that means is after you distribute, there's still, not going to be any like terms. So that answer's done. Just like here, we distributed and we were done because there was nothing else to do. There was no like terms to combine. And I bet it's going to be the same thing here. But okay, this might be something some of you are prone to mess up, unfortunately. So here we're distributing a negative 2x. Okay, we're distributing something with a negative. So what's negative 2x times x to the third, negative 2x to the fourth. Okay, the negative 2 along with x to the first times x to the third. And then we have a negative 2 times positive 9, which is negative 18. And then x times x is x squared. And then we have a negative 2 times a negative 6, which is going to be, oh, I thought I wasn't there for a second, plus 12. Remember, a negative 2 times a negative 6 is a positive 12. And then, of course, the x along for the ride. Okay, so, I mean, again, you could argue that there was nothing new taught in that entire section because it was really just distributive property, but along the way, making sure you're adding exponents where it's, necessary and correct to do so. And, I mean, that's it. So thanks for following along.